Hello everyone, and welcome back to where we left off last time. In this lecture, we'll be discussing two topics, inheritance and special methods. Inheritance is a way to form new classes using older classes that have already been defined. That way, the newly formed classes are called derived classes, and the classes that we derive from are called the base classes. So you derive from the base class. Important benefits of inheritance are code reuse and reduction of complexity of a program. That way you don't have to constantly be creating duplicate classes. You can just inherit from another class and use some of the methods that are available there. So let's see an example of this. I'm going to create a base class, and this base class is going to be called animal class. And the animal class, it needs its initialization method. Remember, that's a special method in it. And here we'll just have self. And then we'll say print animal created. So we're doing very simple class just to show kind of the idea behind inheritance. Usually you won't have a print statement inside of the initialization method. You'll just have self dot and then all your attribute assignments. Then I'm going to create another method called who am I, and we'll call it self, and then this is going to print animal. And then here I'm going to say eat. This will also take in self, and then this will just print eating. That needs to be a string. All right, so a very simple class. It just prints things. When you call these two methods on it, it prints something else. So let's actually kind of play around with this and explore it a little bit. I'll make an animal. We'll call it, say, my A is equal to animal, instantiate that, and then let's have it say something like my A dot who am I, and then my A dot eat. And note, I don't have to wrap this in print because the print is already inside of these two methods. So let's call python nodes.py, and I see here animal and eating. Perfect. All right, now let's say I want to create a new class of dog. Now all dogs are animals, so I want to inherit from the base class of animal. So what I'm going to do here is instead of just passing nothing in these parentheses, I will pass in the other class, which was animal. And I don't have close parentheses here. I'm just passing the whole class in there. And then I'm going to say def init, pass in self, and then when I actually create the initialization, I'm going to call animal dot init, and then pass in self here. And then I'm going to print dog created. So we will save this. And then notice when I ran this the first time, it said animal created, animal eating. So that was for when I created an animal, it said animal created. When I said who am I, it said animal. When I said eating, it said, or when I said eat, it said eating. So what I'm going to do now is save this, and then I'm not going to create an animal. Instead, I'm going to create a dog. And then we'll have this be, let's say it's my dog, who am I, and then my dog here. Now when I save this and run it, python nodes.py, expand this so we can see the output here, it says animal created, dog created, animal eating. So that makes sense because when I created a dog, I said animal here in it self. So it means initialize an animal. And then I'm going to say print dog created. Now I don't actually have to have this initialization line. So I'm going to comment that out. And now let's actually see what happens when I run this. It says dog created, animal eating. So note that even though the class dog does not have who am I or eat methods inside of it, it was able to inherit those methods or derive those methods from the base class of animal. And that's basically the entire idea behind inheritance, is the fact that you can inherit from another class or derive another class. And then you can see here, I can call who am I and eat, even though they're not strictly defined inside of this dog class. Now I can also create new methods here. So I can say something like bark, it takes in self, and then it says print woof. So now I can go all the way down here and say my dog dot bark, close parentheses, and when I run this, I should be able to see my new class wolf. Now I can also overwrite classes, so I'm not strictly limited to everything that was an animal. If I want eat to say dog eating, I can do that as well. All I have to do is just say def and then call eat, pass in self, and then basically write over it. So here I will say now dog eating. Save that. So when I run this again, Python notes, I see that a dog's created, animal, dog eating, wolf. So I was able to successfully overwrite the previous method. And you can check out the notes for more examples of this, but the basic idea I want you to get is that if you've already created a class and you want to use some of those methods in a new class, all you have to do is inherit it like this, and you can then derive from the base class. Alright, so special methods are basically going to allow you to perform special operations, and these methods are not actually called directly, but they're called by specific Python language syntax. Let me show you what I mean by that. Imagine that I create a list, and we'll say my list is equal to 1, 2, 3, and then I say print my list. And if I run this, Python notes.py, I see 1, 2, 3. I've printed my list. Zoom a little bit out. Now what happens if I create my own class and try to print it? So I will create a class called book, and this is going to be a very simple thing so far. We'll say def, we'll pass in our init special method, we'll say self, and this will also have a title, an author, and pages. And then what we will do here is say colon and assign those attributes. So self.title is equal to the title, self.author is equal to the author provided, and then say self.pages is equal to the pages provided. Whoops, pages. Great. And now what I will do is say b is equal to book, close parentheses, and then add in the title. So the Python is the title. We also need to add in the author, Jose, and we'll say it's 200 pages long. And I'm going to say print b, print my book. So this is kind of the exact same thing we did here, except notice what happens when I run this. If I say python notes.py, I hit enter. When I print out my book object, it says main.bookObject at its location in memory. So the question arises, what is the print function actually doing, and how can I get it to print out something that looks nicer? Something that says like title, Python, author, Jose, pages 200. Well, what happens when you call the print function on an object is it looks for its string representation. And right now, we haven't actually specifically defined the book's string representation. We need to use what's known as a special method to do that. And all special methods inside of a class are annotated with 2 underscores, the name of the special method, and then 2 extra underscores. And we can see here the syntax highlighting also notes that they're a special method. And they all need to take in the self argument. So this special method, str, is the string representation of my object. So whenever a function asks for the string representation of my object, and the print function does that, it will return whatever I put here to return. So we'll just say return hello. We save that, and now when we run this, we get back hello when I print out my book. And let's delete this my list, since we won't be using it anymore. So realistically, you're not going to want to say return hello, but instead you're going to want to return a string representation that actually makes sense. And for our case, a string representation that might make sense is something like title, and we'll use some print formatting here. Author, and then let's say pages. And then we will say .format, and we pass in self.title, comma, self.author, comma, self.pages. And we will save this, and let's check to see if we made any errors and if everything runs correctly. Okay, here we go. When I actually called to print b, or print that book, print, the actual function, looked for a string representation, and that was returned by the special method, in which case we got back title, Python, author, Jose, pages 200. And this is how you're going to typically see the special method str for string representation used. Now let's show you a couple more useful special methods. So another special method is the len, or length method. So imagine I call len on a list, 1, 2, 3. I know I will get back the number 3, indicating 3 elements inside of that list. But what happens if I call length on b? Well, I can return or save this and run it. And let's actually print out lenb. But notice what happens. I should get an error. And it says object of type book has no length, which means I need to add in a special method, def underscore underscore len underscore underscore, and this is the length method. So underscore underscore, let me make sure I have balanced underscores. Okay, it's 2 on each side. I type in self, and then what I end up doing is returning whatever I want the length representation to be of my book. And a good representation here, the length of a book, would probably be the pages. So I call self.pages. Note that I'm calling self.pages and not just pages by itself. So now let's see if we can print the length of the book without any errors. And we get back 200, which makes sense because that's what I defined here as the length of the book. So what this length function that's built into Python does is it goes inside the object, checks if it has a special method, len, and then returns whatever that method tells it to return. And then finally, one other special method that you may find yourself encountering, and there are a lot of special methods. As you can see here, all of these are special methods, so anything that is wrapped in 2 sets of underscores is a special method. And there's a whole bunch of them, but I'm just showing you the most common ones. We'll explore more as we continue on with Django later on. But delete is another special method you might find yourself running into, and that's just when you call delete. So I will say print a book is destroyed. And the way you can delete an object from memory space is with del and then whatever the object name was. So now if I run this code, I get back, I created a book, but a book has been destroyed. All right, that's all you need to know for special methods. The most common one we'll probably be using throughout the rest of the course is this one, the str, the string representation. Because if we ever want to print something, it's important that we have the method to do that and not get any errors. All right, thanks everyone, and I will see you at the next lecture where we're going to be walking through a project for you to do to practice object-oriented programming.